Good morning, champs. Today we're going to finish our Centroid chapter with a more realistic structural cross-section. The section is L-shaped and also contains a circular opening. This problem combines almost everything we have learned so far, but interestingly, we do not need any new equations. The outer rectangle is 300 millimeters wide and 400 millimeters high. From the upper right corner, a rectangular region measuring 180 millimeters by 220 millimeters has been removed. There is also a circular hole with a radius of 30 millimeters. Its center is located 70 millimeters from the left edge and 300 millimeters above the bottom. Our goal is to determine the centroid of the remaining cross-section. The easiest way to approach this problem is to begin with a complete outer rectangle and then treat both removed regions as negative areas. The centroid equations are exactly the same as before. The horizontal centroid is the sum of each area multiplied by its horizontal centroid coordinate divided by the total area. The vertical coordinate follows the same principle. The only important difference is that removed material has a negative area. We begin with the outer rectangle. Its area is 300 multiplied by 400, giving 120,000 square millimeters. The centroid lies at the center of the rectangle, so its coordinates are 150 millimeters horizontally and 200 millimeters vertically. Next, consider the rectangular cutout. Its dimensions are 180 millimeters by 220 millimeters, giving an area of 39,600 square millimeters. Because this material is removed, we assign it a negative area. The cutout begins 120 millimeters from the left edge and 180 millimeters above the bottom. Its centroid lies at the center of that rectangle. Therefore, its horizontal coordinate is 210 millimeters and its vertical coordinate is 290 millimeters. Now consider the circular hole. Its area is pi times 30 squared, which is approximately 2,827.4 square millimeters. Again, because this is removed material, we use a negative area. The centroid of a circle lies at its center, so its centroid coordinates are 70 millimeters horizontally and 300 millimeters vertically. Now we place all three areas and their centroid coordinates into a table. The total remaining area is the positive outer rectangle minus the rectangular cutout and minus the circular hole. This gives approximately 77,572.6 square millimeters. Next, we calculate the horizontal centroid. It gives a horizontal centroid coordinate of approximately 122.3 millimeters. We repeat the same process in the vertical direction. The resulting vertical centroid coordinate is approximately 150.4 millimeters. So the centroid of the remaining cross-section is located approximately 122.3 millimeters from the left edge and 150.4 millimeters above the bottom.